it relevant? I'm sure we all have heard in some point of our education the statement that says the energy can't be created nor destroyed, it is only transformed from one form of energy to another. This is dictated by the law of energy conservation, and not everybody fully comes to understand this law and all its applications when solving real life complex problems. The statement of the Cold law means that in a closed system the amount of energy is fixed. Nevertheless, in real life we will never end with the same energy that we started in our system because lots of external forces make it lose this energy. A great example to depict this is a car. You fill it up with gasoline, then the gas flows into the engine, then it is burned, converting it into heat power. The burning fuel makes hot gases that expand, pushing the pistons, and this is the way that we can see heat converted into kinetic energy. Before explaining the theoretical framework, we have to state the hypothesis. In this case, I will try to prove that the gravitational potential energy is less at greater heights and is greater at smaller heights. Well, in a regular roller coaster system, we can measure lots of different energies and we can also calculate them. However, we will only be measuring U, where U is the gravitational potential energy and can be calculated with the next formula. U, as I mentioned earlier, is the gravitational potential energy, which is equal to m times g times h, where m is the mass of the object, g is the acceleration due to gravity, and h is the height above the surface of the roller coaster. For this experiment, we will have three kind of variables: the dependent one, the independent, and the control variables. The dependent variable, which is the one that we will be measuring, is the potential gravitational energy. The independent variable will be the height, and the control variables will be the acceleration due to gravity and the mass of the object. Now, uh, before starting, we have to get these materials. A Hot Wheels track to build the track. Uh, this is because of the current situation. We have to get another type of materials. A cardboard or bond paper, a medium-sized square or box made from cardboard, silicone gun, silicone bars, masking tape, scotch tape, or any kind of tape, a permanent marker, a large and wide wall to mount your track, a toy car, a measure tape, a scientific calculator or any software you want capable of doing complex operation, a weighing machine, and a ladder. And now let's move into the experimental design. The first step is that you have to find a large and wide wall, preferably 2 by 2 meters long. Paste the bond paper in the wall. The amount you will need it will depend on how big is your wall. Then after pasting your bond paper, you have to mount your track with hot glue. You can mount the track however you want. You can do loops, bumps, whatever you want. Then you have to take your toy car. Then you have to measure its weight and plug it into the table. Then measure the initial height from which you will be letting go the car and calculate the initial gravitational potential energy. After that, you have to grab your cardboard square or box and put it in a lower height than the drop point. Then let go the car, and when it stops, you have to measure the height in which the car stopped. Then mark it in the bond paper behind, so this way you don't repeat the height. After doing this, you have to repeat step 7 and 8 with 4 different heights, each one lower than the previous one. And finally, after collecting the 5 different heights, you have to calculate the gravitational potential energy at each point. After making my experiment, we got the next results. For the weight of the car, we got that it weighs 0.0322 kilograms. The initial height in which I dropped the car was 1.5 meters, and the initial gravitational potential energy was 0.471 joules. And as you can see in the table, um, we started measuring from lower heights, which the lower was 0.710 meters, and so on until we got 1 meter point 20. And then we have its respective gravitational potential energy. Um, we can see that the graphic shows that when higher the value of the height, we have more potential energy, whereas with lower values of height, we have obviously less amount of gravitational potential energy. Also, we have to pay attention to the initial value of this energy, which is not included in the graphic, but is included in the first table of data collection. So you can go back and watch it in a previous slide. So it is useful to compare the data obtained in the experiment and letting us to have a clearer conclusion. So let's move on with the conclusions. After doing the experiment and analyzing the data previously shown, we can realize that the gravitational potential energy is less when the object is near to the floor, meaning that when your object is closer to the ground, the potential energy will be closer to zero. On the other hand, we will have the maximum gravitational potential energy at the highest point from the ground. So this is why the hypothesis previously planted it is completely wrong, as the potential energy isn't less at greater heights, so it's the other way around. As lower the height is, the potential energy is lower, and it will achieve its maximum potential energy at the highest point. Now on to the troubleshooting. Well, during the construction of my prototype of this roller coaster, I faced a lot of limitations, especially in the materials. I had few materials available to build the roller coaster because of the current situation of the COVID-19. As I initially planned, I was going to use wood. However, this was no longer possible, and I had to use some old Hot Wheel tracks that I had for my setup. Using these tracks made my data collection a little bit more difficult, as I pasted them in the wall with hot glue, and sometimes the hot glue ended in the road, making almost impossible for the car to complete a ride. And this consumed a lot of time as I had to remove those obstacles, and also I wasn't able to build the road as I would like because I didn't have the enough tracks to build a long roller coaster.